My name's Sunny. I'm the InnoDB team lead, and I'm here to talk about what's new in 8.0. So some of the things have been released, and I'll talk a little bit about some stuff that we are working on and will hopefully be released. And that's meant to cover my proverbial. So that's that. So the biggest change for us has been the InnoDB, for MySQL was the data dictionary. So we've combined them into one. And historically, if people don't know this, but InnoDB was meant to be a standalone database when it was written. So it had its own data dictionary, its own SQL parser, and everything else. And the server had a different view of the world, and InnoDB had a different view. And when you made changes to the metadata through DDL, most of the bugs that we've been seeing around this are they would go out of sync, and it causes all sorts of weird issues. So rename, add column, this, that, whatever, anything that requires metadata change was a big problem. So with the new data dictionary, we've got rid of the FRM files from the server, which was the server view of the data dictionary. And InnoDB had its own data dictionary, so it now goes to the server to ask for the metadata. And the server stores its files inside InnoDB, and InnoDB does not do anything special with those tables. They're just server tables that have metadata information. That's all. And it's transactional, and we have to, for InnoDB, the source of truth is the server. It is no longer its own persistent state of the data dictionary. There is a little bit of a catch here, and this is something that I want to sort of get across in this talk. So if you think about it, when you do an upgrade, InnoDB has to know about how it organized its metadata in 5.7, and then take the data over to the 8.0 format. So there will be in 8.0 a transition period where InnoDB knows how to handle both kinds of dictionaries, so that can help in doing the upgrade easier. Because you can't just switch from one to the other. There has to be an upgrade path from 5.7 to 8.0. So InnoDB in 8.0 will internally know about both the old way and the new way. So it'll carry some legacy code and some state around to help with the migration. And this is extremely important. And if there's one thing you take away from this talk, I would highly recommend that you download the current labs release that we have. It's on our website. It's called the 8.0 Unified Data Dictionary. We couldn't release it as part of the DMR. It's in the labs release. And try and see if you can run it, and if you encounter any issues. The earlier you tell us, the smoother it will be for everybody. Because we have great QA, I must admit, but everyone has their own setup and their own configuration and all sorts of weirdness that we can't test. So if you can download it and test the upgrade and give us feedback, we will be very grateful, and it will help you. It will be good for everybody. So if you could do it, highly recommend it. So InnoDB had its own mutexes and latches and stuff like that, like the dict-sys mutex, the read-write lock, and the server had its own infrastructure called the metadata lock. So they are all now going to be under the metadata lock. Because we've got this hybrid business in 8.0, we still retain some of the artifacts from 5.7, but eventually they will all go, and we will use the cache, metadata cache from the server. But currently we maintain two separate caches because we have to handle the special case of the migration from 5.7 to upgrade. And it'll be crash proof, and it will be atomic, which was never the case. If you have any questions, by the way, please feel free to interrupt me and just ask. So as I mentioned, one source of truth, atomic, no more yeah, okay. So this is more or less what I just mentioned. This is probably the most important part, the last line. And the last two lines. So Up to 5.7, the server has no idea of table spaces, and InnoDB deals only in table spaces. The server only has a concept of a file, which is FRM. The FRM file is mapped to a single file, a single table, which is a single file. InnoDB in a table space can have multiple tables. And the server wasn't aware, didn't know anything about this concept, so it was a bit of a mismatch there. Now it's all held together very well. The server knows about table spaces, it knows that a table space can have multiple tables, it knows what to do, it can do the locking correctly. Earlier we had to jump through hoops and do all sorts of weird stuff if you had multiple tables inside a single table space, a feature that we introduced in 5.7, for example. And some of the things that we could not do with the so-called general table spaces in 5.7 is because of this missing feature inside the server. Also now for temporary tables, we don't need to create the metadata on disk, if you think about it. InnoDB has never stopped doing that in 5.7, but the server would still write out the FRM files, and temporary tables are meant to be fast. Their life cycle is meant to be fast. You create it, you do some stuff, and then you throw it away. And you don't care about the contents on a restart. So there's no need to do extra I/O with the FRM file. So that's all gone. The server does exactly what InnoDB used to do. So they'll be a lot faster. I don't have any numbers, but it should be faster. This is what it looks like. And as I mentioned, InnoDB, it still has a bit of that legacy. It's got a cross, but it will exist for the upgrade. But eventually, it relies on the server as the final source of the truth. And the other business, it's only for upgrading. It's not for general purpose. Once it's upgraded and running, it's just dead code that sits there and tables that will never be used. And one of the plans we have is, which is not there, is to get rid of them and also truncate the file, and it'll make this one problem that we've been hearing about for many, many years, which is that the IB data file is too big and you can't reclaim space. So that problem will hopefully go away. Once you do the upgrade, move the undo logs out of it, and then maybe just have 3-4 pages for some control information. That's our target. So one other thing that I'll get to it later, but I'll just mention. One of the core subcomponents of InnoDB are the undo logs. And historically, they were always inside the IBD data1 file. And that's what makes it very big. And you can't reclaim the space, and it's a bit of a mess. And in 5.6, we added the facility for creating undo table spaces outside of the IBD data file. But once you created it, you couldn't do anything else with it. In 5.7, we added the facility to truncate undo table spaces. But if they were not created outside of the InnoDB system table space, so if you have some legacy system that you're upgrading, you couldn't make use of it. And this is, we know this was a problem, and not everybody has the luxury of starting from scratch. In 8.0, because the server knows about table spaces, we are moving to the Oracle style of using SQL or syntax for create undo table space, drop undo table space, and managing it dynamically. And because the server is aware of all this metadata, it makes it easier for us to even allow facilities like have an undo for a schema, or this undo is only for this table space, or this undo is only, just like Oracle, like rollback segment for blah, and then in theory you can then have some mechanism to assign the rollback segment to a transaction that only deals with this group of tables, and that rollback segment is somehow attached to those tables. So all this will become easier to do with this metadata change. So this is a bit of a digression that I wanted to mention. So we've added some statistics gathering to our buffer pool to help the cost-based optimizer, which you must have heard about, which Mani must have mentioned. So that's some work that the two teams have been doing together. We've changed our buffer pool mutex. This was a contribution from Percona. And I must say that we spent a lot of time in fixing the bugs in the contribution. And I'm sure people here have been using that server in production, but it has some serious bugs. So, well, we found two, and two serious ones. And And you've acknowledged it, I know. So, but I must admit, it's a great idea. We like it, which is why we took the patch, and it's something that we can build upon. So, big thanks to Percona. But it doesn't come for free. It's a huge amount of cost for us. Then we took a good patch from Alibaba. It splits the redo log writes in mutex into a write mutex and a mutex that works on the buffer. So there's a bit of improvement in throughput there. So this is what we've got at the moment. We are thinking of improving upon this, but this is what we currently have. I'll mention some of the things that we've been working on, but later. So this is again this is a very big thing for us, and this is all because of the new data dictionary. So you can do the create undo table space. So this is the exact syntax is still work in progress, but it will look something like this. One big thing is the first point, which is the change of the undo role pointer format. So it's a 7-byte column that's a hidden column inside the clustered index. So the way InnoDB works is when you do a change, it copies the delta that's required to rebuild, to undo the change into the undo log, and it's a chain of the list of records. And because InnoDB was always meant to work on one table space, those 7 bytes are done in a way where the number of rollback segments is what decides how things are allocated. And we want to move to a more table space oriented thing. So because of that, we will change the undo rollback pointer. There is a subtlety here which has a huge impact, and that is, this is the equivalent of saying that we are changing the row format, and intuitively you will think that I have to now, if I've got like 10 terabytes of data, that I have to convert all the data. That's what it is. Because if you're moving to this new system, there has to be a conversion, but we want to avoid that. So one big effort that we made in the data dictionary project is that we want to avoid forcing the user to change their data. It should be a painless and easy affair. Just the metadata should change. So when you see something like this, oh, you're going to change the undo role pointer. So the plan, this has an implication. The upgrade will be a lot easier if you do a slow shutdown. That's why I'm very keen to hear stories from people on how they manage, what problems they have when they tried an upgrade. Because this will have an impact in the upgrade. Your undo logs should be empty, and it should be truncated ideally, and then it's painless. Because InnoDB will never follow an invalid pointer. Because if it tries to parse it, there is a bit of debate internally, so we are still thinking of solutions where we may support both. It's not fully decided yet. It just depends on a few things. So, and as I said, we want to make it painless, so we may support both, but I'm not sure yet. This format is changing. And the reason for that is that we will now rejig the bits so that the table space ID is the dominant thing and not the number of rollback segments. So that you allocate the number of table spaces, and then within that you can have gazillion rollback segments, rather than the current system where you have 127 rollback segments and you can have to spread them over table spaces, which doesn't make sense. So we have to make this change to make it align with all the other big changes that we are making, make it more flexible and for our future work around this. So please, very important that you try this upgrade business and see what sort of impact it has on whatever your test data or test schemas that you've got and stuff like that. So this was the first thing is a feature request that came from Facebook. They want to group the rows inside purge so that it reduces random I/O. So and the threads don't. If you have multiple threads inside purge, and you just randomly hand out a batch of records to the purge threads, there's a tendency for them to contend on the same index mutex. So this was a request from Facebook, and so that's also done in 8.0. There's also a new variable called InnoDB stats include delete marked, and that means that when collecting stats, you can tell InnoDB whether it should consider delete marked rows or not. It affects your optimizer cost estimates and stuff like that. So it's probably important for certain queries, so something to pay attention to. There's a new variable it's been in some of the forks, which is InnoDB deadlock detect. So we've also added this finally after 4. It's like such a trivial change that's just been slipping through the cracks. It's not like nothing. It just slipped through the cracks, that's all. So on high concurrent loads, you rely on the timeout rather than the InnoDB deadlock manager check. That's basically it. So that, depending on what sort of load you have, if you have too many threads contending for the same lock, there are more deadlocks, and the deadlock check becomes expensive. You go, no, I think I will reduce the lock weight timeout, and I will handle the rollback. So the rollback is faster than the deadlock check, so you on, off, you can try it yourself. So the last point is something internal again to InnoDB. So InnoDB has always, historically, it was a separate thing from MySQL. So it did its own prefetch when the server requested rows, and it had a heuristic to determine how many rows to prefetch. And it seems to work well enough, but it can be improved. So now the optimizer actually knows how many rows to fetch. So it tells InnoDB, I want so many rows in the prefetch, and this has had a 20% or some 15% improvement in performance. In scans. So InnoDB doesn't have to second guess.
All thread counts too.
All thread counts?
Single thread, all thread.
Yes. It's a generic sort of fix.
What redirects your default value?
Beg your pardon?
Redirect default value without like how many rows it fetches?
The
28K. Based on the disk type, SSD is something
No, we don't have it.
No, I mean, it's sort of a little bit different from read ahead. It's just like a pre-allocate batch buffer because it knows it'll need the rows anyway. It just basically reduces some.
InnoDB MTR overhead, mini transaction overhead, and copying overhead. That's because it's easier. InnoDB likes to batch it. It's not a correctness issue, it's like a performance issue. So if it went through the whole rigmarole and just returned one row, it's expensive. There's an overhead. So it had this heuristic that it would say, I'm going to prefetch so many. It doesn't know what the server wants. So it applied some heuristic and fetched, 8 or something like that. Something like that. And it can be improved because the optimizer does know how many rows it wants. So there's no need to, and it's it's now like one product, so it's better to make it faster and better. So we have these encryption in 5.7, but we did not encrypt the redo log and the undo log in 5.7, and of course it fixed the use cases we were after, but to complete it. In the current release, you can even encrypt the redo log and the undo log, and the dynamic. So you don't have to just set it at startup. You can dynamically say, start encrypting the redo log or start encrypting the undo log. We will support encryption, compression, and import, export for shared table spaces, which were introduced in 5.7, but we did not support any of these three things. And the main reason for compression and encryption, for sure, is the data dictionary. We did not know where to put the attributes in the server. Because the FRM file is a per table thing. So if you say, I want to encrypt this table space, and the table space has 4 tables in it, which FRM file you set the flag in? You don't know. So we hacked around a bit. The system used to work internally inside InnoDB, but we didn't know where to put the metadata. So now we know where to put the metadata, so this works. How many people use Memcache? 1, 2, 3, 4, 5. Wow. About 10 people use Memcache. I nearly took it out of my slide. I just thought nobody uses Memcache. Good. So yeah, we support, in the current release, we support multiple get and range search. So please try it and tell us if you need anything else. Really. Persistent auto ink bug number 199, created in March. So this has finally been fixed. As embarrassing as it looks, 14 years after the bug was filed, it's finally been fixed. So you can go there. In fact, I would again recommend that people try this out, because if there are any performance issues, and this is such an important part of any database, it's better we know about it earlier than later. Really. So if you can kick the tires, try this on some high load server, give us some feedback, please. Very important we get this right by the time we go GA. So there's a new view, information schema view. It'll tell you the number of cached. So if people who sort of follow this sort of stuff, I'm going to speed up a bit because I've missed a bit of that. I'll just quickly go over this. So we have descending indexes. There are some restrictions which are up there. So if the secondary index contains a descending, change buffering won't be used for both those cases. It doesn't work for the R-tree and full text indexes. But it works for the virtual and stored, which are part of the JSON story, so it works for all that. So it's all, for I would say 99% of the use cases it works. Another important feature, so if you have the update, or you have the no wait or the skip locked, for no wait, when InnoDB will scan the rows, and if it finds if the deadlock, the lock manager says, oh, you have to wait. If that is set, it just returns immediately. If it says skip lock, it'll skip that and go to the next row, and if that's not locked, it'll return that row. So again, you must have seen an example in Gary's talk probably. Yeah. So we moved to C++11. It's a big deal for us. And what that means for us in practice is that we are going to get, for people who hack on our code, this is important for them. We're going to get rid of all our homebrew atomics, our homebrew lists and this and that, and just switch everything to the whatever the the C++ libraries are. We have a stronger memory model, and so things will only get better. So it's a big deal for us. So and for people who like to write tools, we are trying to make libraries like the libInnodb zip compress so that you can take that and just write tools using whatever. So we've isolated the code so that it can be compiled and built separately. You don't need the whole shebang to do stuff. So that's that. So we're moving towards the whole C++ thing. So this is not so important. I'll just go. So this has one very important change, which is the InnoDB scan directory. So in 5.7, we made a change where we keep track of the table spaces inside the redo log. One problem with that is if you lose the redo log, you lose everything. I mean, so let's say some files weren't written to, and you should be able to read them, but InnoDB won't know where to find them. So there's a little bit of a weakness there. So what the InnoDB scan directories does is that if for some reason you move files around or God knows what, you can tell it to search in certain directories rather than just blindly go with the redo log. So in the current release, there is a slight gotcha that it doesn't update the data dictionary yet. But when it's sort of everything falls into place, once it's discovered the files and figured out if manual intervention is required in case it finds 2 files and stuff like that, once it's clean and starts up, it will also update the metadata for you, and then you can proceed from there. So this is something new. So InnoDB read-only, anyone who's using it, now it affects the entire server, and the reason for that, I should mention, is that because the data dictionary is inside InnoDB now. So if InnoDB is read-only, the server is read-only. We did lots of bug fixes. I won't go over this. So future. We plan to add, so this is not in, but we're working on all this stuff. So we want to add versioning for table spaces. And this is an extremely important thing for us in the long run. Currently, it's very difficult for us to change the format of the row, the page, or table space, or whatever. So our plan is to store the version number inside the new data dictionary as a storage engine attribute. And then all we need to change in our code is the serialize and deserialize of the page or the row. And then we can have multiple formats. So if, for example, R3 requires a completely different page layout, it should be easy to do with versioning on our pages or at the table space level. And for example, if you want to support the server row format, which is a MyISM format, by having a versioning for table spaces or rows, it should be very easy for us to do it. So these are all the benefits we're going to get from the new data dictionary. So this is all future work. So yeah, I'll sort of skip this, except for the SDI. So this is something new. One thing we are trying to do is have the table spaces contain the data dictionary or the metadata for the table space itself, so it's self-contained. So in a worst case scenario, you should be able to take a table space, create a brand new server, and import it with the metadata written already inside the table space. And we call that the SDI, which is the serialized dictionary information. So it'll help us in export and import, crash, disaster recovery, so that's the aim there. And this data looks like this. So if it's corrupt, you can extract it. There's a tool for extracting it. You'll get a text file. You can edit it to match whatever the size or whatever schema, and then use that for importing the table space into your new instance. We've got a new memory storage engine to replace the old one. The main point is the last one. I won't go over the other ones. It uses less space. I think Booking.com had an issue with this, the space thing. Yeah, so this is the replacement. So better blob handling, I'll skip. So this is the tool that I mentioned earlier. And yeah, it sort of mentioned that. Yeah, so we are also working as part of the whole upgrade thing that for people who want to extract the undo logs out of the system table space, we plan to have a tool that does it for you. So you run this tool on a instance that is shut down, and you give it some parameters that create so many undo table spaces, so many rollback segments, and it can take that from the system table space and create those files for you, and then it makes the upgrade much easier. So that's also coming. And the other thing it's going to do is it's going to look at the last page which is still in use, which could be because you've got some large system table space, or table inside the table space, and it's like 50, 100 meg allocated in some extent, 100 meg down. But after that, it knows that the space is free. It will also truncate it there. That's the plan. So you will also reclaim space for people who have large IBD data files. So this is something that Morgan wants to do. So a variable that says dedicated server, if it's true, then it sort of automatically tries to figure out how to configure the buffer pool and the redo log and stuff like that. So I'll probably quickly go over this. This is a big change. This is again what Dimitri's been making a lot of noise about this. So the current semantics are the InnoDB flush log at transaction commit is equal to 0, 1, 2, as 0 is once a second, 1 is write and flush at each commit, and then write at commit flush once a second. So if you think about it, these days on modern, this setting is like 15 years old, 16 years old probably. It's very old. And in those days, if in 1 second you lost 20 transactions, maybe 5. But today, if you're doing 100,000 transactions per second, you will lose 100,000 transactions. So the variable really is a bit weird now. So we are changing it where you can set it to the number of transactions after which you flush. So if you set it to 1,000, it means every 1,000 transactions it will flush. Not just once a second, because then once a second can be a very large number of transactions now. So there'll be some fine tuning required, I'm sure. This will generate some revenue for consultants, I'm pretty sure. We've been working on this stuff, which is still in prototype stage, but extremely encouraging, very good. I genuinely wish that we can push it. And we made it lock-free, transaction lifecycle. MBCC is latch-free. Deadlock checking is way faster. We've rewritten and re-architected the redo log completely. And we fixed the I/O contention around the file system mutex, and I'll show you some of the. I'll show you. This is the more important one. So this is like a typical Dimitri chart. So the one to pay attention to is the last one. So that there is. I mean, just look at the colorful side on the left. That's just mutex is going mad. And look on the right, it's all gone. I wish I could show you the numbers, but because it's still prototype, I hesitate. But the numbers are fantastic. Let's just say that. So this is a big change. I hope we can push it, and it gets rid of all the main problems that we have around performance in InnoDB in write-heavy loads. Thank you. So, any questions? Sorry, any questions?
Share the slide somewhere.
Yeah, it should be on the Percona, the talk thing. The lady just took a copy, so she'll put it. Any question?
About the SDI in the table space, the information about the table, it looks like we begin to have a lot of potential source of data. So how do you ensure all of that is consistent?
Okay, so there's a heuristic there. The data dictionary is the main thing. Okay, where do you need it? The question is, when do you need that data, right? So when it's running, we just write it out. So we don't really make any consistency check with the data dictionary, none. It just writes it out. If the writes succeed, fine. It's when there's a disaster and you need to pull it in. That's the only time. And then if you have your own schema and that doesn't match, we keep it in two spots. You check both, see which one matches your schema closer, and then either you modify your schema if this is out of sync, or you modify this file if this was written. And you can experiment with it, I suppose, and you modify. This is like for disaster recovery. This is not really for yeah.
So previously there were two types of dictionary, right? Now you may say there's two types of dictionary because there's SDI and there's dictionary. What's different? There's a big difference. There's a single source of truth, and that's always the data dictionary, and we always go to that first. So the SDI is used for data recovery, and it's used for import, export scenarios. So if there's any discrepancy, we know what's more important.
So the data dictionary in the server is the source, one source of canonical.